We are to solve for n in this equation. We have our radical terms on one side of the equation, so our next job is to use the power rule and square both sides of the equation. Now when we do this, we cannot just distribute this squared term here and here. What we have to do is we have to multiply all of this out using the formula we've learned or using FOIL. The formula we've learned is a plus b squared equals a squared plus 2ab plus b squared. So following that formula, we get a squared plus 2ab plus b squared equals 25. So anytime you have a radicand that it has a square root and you're squaring it, you end up with just the radicand and no more radical sign. In the second case, we're going to have 2 times, and we can combine n minus 11. And remember, this is a product. They're being multiplied, not added. And then in the last case, we just have n plus 4. So now our task is to multiply out what's inside. So first is n squared, then outer is plus 4n, inner is minus 11n, and last is minus 44. And all of that is under a radical. And then to simplify that by combining the middle two terms, we get 4n minus 11n is negative 7n. So now we combine our like terms. So we have 2n minus 11 plus 4 is minus 7 plus 2 times our radical, which is going to be n squared minus 7n plus 44. All of that is equal to 25. So now we have a new problem, essentially. We need to get our radical term by itself. So we're going to subtract minus 2n, add 7 to both sides. And we get our radical term on the left, n squared minus 7n plus 44 equals, and then 25 plus 7 is 32 minus 2n. So our next job is to get rid of that 2 by dividing both sides by 2. That leaves us with n squared minus 7n plus 44 on the left. Whoops, the square root of that. On the right, it leaves us with 32 over 2 minus 2n over 2. The reason for that is we had this numerator, 32 minus 2n, over this denominator, and we learned earlier that if you have a polynomial on top and a monomial on the bottom, then you can divide each term of the polynomial, each term of the numerator, by that monomial denominator. So this gives us 16 minus n on the left. At this point, we're ready to use the power rule and square both sides. So that gets rid of our radical sign on the left. And we use our formula again on the right. Only this time we have a minus sign. So that gives us a squared minus 2 times a times b plus b squared. So that gives us 16 squared, which is 256. 256 minus 32n plus n squared. And I just realized I made an error. This up here, let me point to it. Up here should be a minus sign. Let's subtract everything on the right from the left in order to get 0 on one side of the equation so we can solve for n. So we're going to do minus n squared plus 32n minus 256 minus n squared plus 32n minus 256. And that gives us 25n minus 300 equals 0. We add 300 to both sides and then divide by 25, and we find that n equals 12. But we're not done. On a problem like that, we want to make sure we got the answer correct. So we plug n back into our original equation, and n is 12 minus 11 plus the square root of 12 plus 4 should equal 5. So 12 minus 11 is 1. 12 plus 4 is 16. Square root of 1 is 1. Square root of 16 is 4. So 1 plus 4 does equal 5. So it checks, and n equals 12 is the correct solution.